It certainly is my pleasure to be able to participate in another IGAC meeting and to do it in this capacity, and both allowing and having thanks to IGAC for helping us celebrate our birthday with you. IGAC has been a long-term and important collaborator, and as Oksana said, we share a lot of community, a lot of common interests, and so that's great. Before beginning, I guess I'd like to show, by a show of hands, how many people have or are or have served on a scientific advisory group. Raise your hand. Or an expert team, or participated in GAW training, or been a GAW trainer, yeah, or have been supported by to attend a GAW-sponsored workshop or training session. Okay. So again, just another sign of this community interaction, commonalities between IGAC and WMO. So today, what I'd like to do is share with you the current status of GAW as it exists today. I'd like to go into a little more history about how it came to be, and then certainly share with you some ideas where we might be headed over the next, hopefully the next couple decades. Again, I like this poster. Again, thinking about GAW, we sit within a meteorological organization, an international organization. Weather, climate, and the air we breathe are really components. If we look back 25 years ago, the air we breathe was a component. It was mentioned, and I'll talk a little bit about that history. But I think today, within this WMO environment, the air we breathe is really connected in ways, in stronger ways than it has been in the past. And I think that presents a really great opportunity for us, the community, to think about our research from the atmospheric chemistry composition perspective and how that connects to climate and weather. Because I think many of us feel we're in this game not only because of the excitement for the science, but also we have some problems to solve. We care about the environment. The environment's in need of some attention, and we can do better. And I think that's another motivating factor. And one of the ways we can do better is embed our research and see that our research gets transitioned to better services. And so that's going to be a theme that will resonate throughout my talk today, the few minutes that I have. And again, the overall motivation, research conducted on atmospheric composition, accounting for the human impact on the atmosphere enables better services. So I like to think about what we're doing in research, fundamental and applied, is really setting the stage for a whole bunch of exciting things that we don't know for sure where it's going. But one of the outlets will be, in some cases, better services. And I think if we keep that in mind, then anyhow, at least for the next 20 minutes, let's keep that in mind. So if we look at the GAW mission, the GAW mission is to systematically measure the chemical composition and UV radiation of the atmosphere. It's to use this information in analysis and assessment in support of international conventions. That's been an application. Think about stratospheric ozone depletion as just one example. And also to develop air pollution and climate predictive capabilities. This has always been a concept for us in GAW, and again, just like this service component, this predictive capability and the role that we have in this community of helping that predictive capability in weather, climate, and the air we breathe is really, I think, at a time where we can really begin to realize that. And there are some great examples out there where that realization is already finding its way from the research community into the applications community. And one great example is the GEMS Copernicus transition activities. Okay. So let me take just a minute here and talk about this organization, and it's wonderfully filled with acronyms and abbreviations. Okay, those aren't so important at this point, but I'm just going to spend just a couple minutes here. So if we start at the top, we're really talking about the expert groups. That's the EPAC Scientific Steering Committee. That's the committee that I chair, and I'll introduce a little bit later the members of that current committee. The scientific advisory groups are really critical to guiding the science and the measurements that take place. We currently have 6. We have ozone, UV, reactive gases, aerosols, precipitation chemistry. Those are all around parameters. And the first cross-cutting activity is the gourmet one that I helped with Lisa to help form and guide for the last many years is really focused on this cross-cutting urban environment activity. We also have expert teams, and world data centers and near real-time data flows are a couple examples of those. And this organization keeps evolving as the needs do, especially in terms of the expert teams and task teams that are developed. So that's at the highest scientific level. That's where many of the scientists are engaged and where practical interactions take place in guiding the program. We certainly have then the administrative management, which is sits in the Secretariat, and Oksana and her team. It's a small team of really dedicated and talented people that are helping interface between the scientific advisory groups and the boots on the ground that are doing the measurements and carrying out all the interactions within the WMO organization, which is formidable in terms of administration. 190 countries, a lot of organization, voting by consensus. It's, you know, you can imagine it's a difficult but necessary environment to operate. The third level that you see up there are the central facilities, and that's one thing we'll come back to all along. I think one image that I hope the GAW program has is its focus on quality assurance and reporting and collecting good data, and data that can be combined. And that's been a theme from the day one in this organization, and that's very important. But to make that happen, we have the QA and components, we have the World Calibration Centers, we have the Central Calibration Laboratories, the World Data Centers, and then the GAWSys thing there that you see is really helping to collect and disseminate the data from these different groups. And then the fundamental components is really the hardware, is the contributing networks that made up of the GAW stations, which form, these are global and regional, and in the future another local component will be added. It has contributing networks, so many of you are involved in observations or networks that are contributing to GAW, so that GAW is one piece of the puzzle. There are many other pieces of the puzzle, and the better that we can coordinate those, and we get a better picture of what's going on and a capability of monitoring the atmosphere. We have aircraft and satellites, and then we have a whole bunch of user applications. We are responsible for contributing to parties of conventions. We have systems that we're aware of, GCOS, GEO, et cetera. Program interactions, like one of our great partners, IGAC. We interact with operational centers as well as research projects. So this gives you the overall framework of GAW. And so it really is a large organization, and so it really takes a village to make this happen. And most of that village is made up of volunteers that are really think about this and contributing from the science perspective to this global observing system, and see the value of collaboration and using this. And so we'll talk a little bit more about that. And one of our main components are these global stations, and this is a snapshot of the global stations as of June 2014. And these global stations are stations that are required to take multiple observations of multiple parameters for long-term commitment. And we'll come back and talk show some examples. But you see that we do have a fairly nice, currently 30 stations, global coverage that allows us to do a lot of interesting analysis and analysis. So let me talk a little bit about the evolution of GAW. Oksana said yesterday, if you heard the opening ceremony, that it was established in 1989. But it really has a long history that I think is really important for us to understand, again, from this idea of this relationship of what we're doing from atmospheric composition to the weather community. So it was formed in 1989, a combination of this global ozone observing system, and that was established in 1957, one of the years of the International Geophysical Year. And that's going to be quite important. We'll come back in the next slide. I'll talk a little bit more about how these big global community events can really lead to moving science and the observing systems forward. And then the Background Air Pollution Monitoring Network, BATMON, formed in 1967. So those are two existing components. I'll talk in just a minute about the longer history of the ozone observing system as one example of why it's important to have these global observing systems. And then the BATMON, formed together in 1989. But I think the other component to put in mind is that GAW came about not only because of these existing programs, but because of the context of the time. If we think back to the 70s and 80s, so that's when 1970 I graduated high school, very interested in environmental issues, a lot of things happening. And these are just some collections of images for 1970s and 1980s. We'll just start at the top. That's a photograph of New York, 1970. Looks a little bit different today. The upper right, you can see that also in the 1970s was this emerging understanding that, in the 70s, emerging understanding that human-produced chemicals might have an impact on stratospheric chemistry. And then a little bit later, of course, we understood that, yeah, it happens. And that's one cartoon. Certainly acid rain was in the mix. That was really the awakening that starting in the 1960s, but certainly in the 70s, this understanding that, yeah, okay, humans could pollute our local environment, but we didn't have much impact on the larger scale. Well, the wake-up call certainly came when the acid rain problem. And then certainly this idea of the greenhouse gases, the greenhouse effect was certainly in the 70s and matured in the 80s in terms of, you know, we also are maybe having an impact on controlling the temperature. And then there was also this exciting time of society saying change is in the wind, you know, Earth Day, April 22nd, and one of my favorite cartoons is Pogo. And certainly the comment that he wrote that I think galvanized me and others, we have met the enemy and he is us. So a real wake-up call that, again, we have a role to play both in the problem and in the solution. Okay. So again, we merged these programs together in 1989, but there were these two existing programs. And one, again, was this idea of this international ozone, global ozone observing system established in 1957. But if you actually go back further, the International Ozone Committee was established in 1933 under the International Association of Meteorology. And it was brought in under that time period because even then there was this notion that if we understood the compositional variation of total ozone in this case, we could better understand weather. Okay, so they had that concept, and so they were beginning to bring in formally into the meteorological world this idea that composition could matter, okay, from a meteorological perspective. And there's a wonderful history that's been written by Rumen Boshkov in 2010 about this commission and committee. But again, here's this wonderful picture that for the second meeting, the first meeting was held in Paris, this meeting in 1936. You can choose your favorite scientist here. You can see it was chaired by Dobson. You can see Engstrom was there. You can see women participating in the first row. So again, formed in 1933. Okay. And one of the things that happened in this, so 1933 they got together. There was this, you know, ozone was discovered in 1840s. Beginning to measure it, a lot of interest in optics and absorption, characterizing it, and then applying it for measurements in the atmosphere. And so this group got together to discuss methods, advances, etc. But they were done in a pretty ad hoc way. And I think this is a great lesson for us. So in 1957, galvanized by the International Geophysical Year, and also by the fact that WMO was established in 1950, so now you had this international organization put into play. And then in 1957, then this, they were able to really expand the observational network. So it went from prior to 12 stations prior to 1951, no coordination, sporadic observations, difficult to put the observations on a common standard to say anything about what was going on. Then galvanized again by both the opportunity of the International Geophysical Year and by the fact that there is a need for some organization to look after long-term measurements and work towards ways that we can put measurements together, and that was WMO. And then it quickly expanded then to to over 32 just in that 1-year period, and now it's grown from there substantially. And I think this is a great example of putting into play a global observing network for reasons that were both driven scientifically, and also this notion that having this information was going to inform us better about weather, upper atmosphere weather, etc. But it was great because now we had the community that had already been existing. Now another leg that they can stand on is this organization. And then, of course, having this in place was very fortunate when we began to see and think about this stratospheric ozone destruction in the polar region, and so this network was actually able to detect that. So it wasn't put into play for that problem specifically, but it emerged as another tool to help that we had that in place to look at a problem that wasn't anticipated so far ahead of time. And that is one example of taking the ozone observing network, which now has expanded tremendously. This is now a picture of the GAW evolving ozone. We have ozone observations not done by WMO, certainly, but by space agencies. We have aircraft observations. We have surface observations, all coming together, being calibrated so that they can be put on the same scale. We have an archiving system for that. We're now moving more even towards real-time applications so they can be used in forecast analysis and leading to global products. And these products exist both in terms of model output, certainly in terms of public warnings. We have the Canadians that have put up, as one example, putting up a UV radiation operational service available globally. And we have the important WMO Antarctic ozone bulletins, again, a service product that's telling the community, allowing the community to keep track of what's going on. So one example, again, of taking observations from early time, embedding it into a global inventory, and then allowing it for uses, for many uses. Another example is evolving research to services is in the greenhouse gases. We can look at this picture on the top. We see the first meeting of the greenhouse gas experts. This is done at Scripps Institute, and you look around the table and you can see Keeling and all the other, many of the other people from around the world who are interested in measurements of CO2. Those meetings have been taking place with a regular schedule since then. I show you the 17th meeting of this expert measurement group done in Beijing just last year. You see the community continues to grow. And again, it's a great example of putting together an observing system. At the time, the Curiosity in 1958, yeah, there was interest in the kind of the greenhouse theory, but certainly the ability to measure, the first measurement starting at Mauna Loa in 1958, but certainly wasn't put into play for a specific problem, because if you just look at this cross-section of covers of Time magazine as just one example over at, a 3-decade, or whatever, nearly 4-decade, warming, cooling, where are we at in this problem? And again, the observations that we had put into place allow us to better understand and document in these perhaps trends that were not either thought about and thought wrong or not. So. And that continues to evolve. So again, we have this observing components of, at least within the GAW community, the ability to do an integrated atmospheric carbon observing system, the GAW framework, and again, you can see the pieces of the puzzles again, going from satellites to ships to those global stations around the world, to the aircraft measurements, and we heard even additional aircraft measurements being done today by JMA and the Total Carbon Column Observing Network. All of these, both between GAW and contributing networks, we can now have the capability of really looking at greenhouse gases on a global scale, and this allows us to look at a lot of different things, one being treaty and convention, if we ever get a global policy on greenhouse gas emissions, and certainly verifying emissions and fluxes are many of the applications that come to mind. And a service that's coming out already is the WMO GAW Greenhouse Gas Bulletin, which is very, very important for policymakers. The last one came out in August of 2013. And for the first time, including observations within the GAW network of ocean acidification, measuring at routine spots both the pH of the ocean water and the carbon dioxide in the ocean water. And you can see from these slides, I won't go into detail, but you see the dissolved CO2 increasing, the pH going down. Important message that's been added to the bulletin. So with that, so those are some of the elements, again, so message that GAW has, or at least WMO has recognized the importance of atmospheric composition, mostly from the beginning, mostly as a notion for its impact on weather, but again that's merged within 1989 within the GAW framework and continues to grow. What I've listed here is really the foundation of GAW. It's, let me read it, collecting adequate information on the chemical composition of the atmosphere and on the consequences of the anthropogenic impact on a global scale is valuable. Okay, so that's the starting proposition. But is only possible if all relevant measurements are expressed in the same units or on the same scale, and if data from the countries and at different sites are comparable. We have to be able to combine data if we're going to be able to tell a story. Okay, and I think that's been, from the beginning of GAW, that has really been the defining proposition and the motivation for doing it. And in order to do it, put into place, I think, a very, very nice infrastructure and organization to do their best to ensure that that is possible for the parameters that they are most interested in. I won't go through this diagram, but again, you can see the interactions of the scientific advisory groups, the calibration laboratories, the data centers, the quality assurance, scientific activity centers, the World Data Center, and the people at the sites themselves. So again, it takes a village to make a good measurement that is going to be able to compare to a measurement taken in Norway, Brazil, Argentina, wherever we might be taking that measurement. And these are just some pictures showing those interactions that take place, intercomparison of instruments, and you see in the lower left-hand why it's important. The stability of the world standard, over time, we can really document that. So we keep coming back to being able to reference our observations, which enables us. And in the lower right just shows some of the evolving instruments. If we're going to come up with new ways of doing ozone sounds, different methods, we need to be assured that they're going to produce observations that we know what's going on and that we can combine them on similar scales. Okay. So with that commitment to high quality data with the global long-term vision of observations that has been now going on and emerged and continued to evolve over 25 years with a longer tail going back decades before that. We now have a high quality long-term data, and with that enables lots of things. And for this discussion, global assessments and analysis. And I'll just show you a couple examples of this. Example of a recent study that the Precipitation SAG and their colleagues put together looking at a global assessment of precipitation chemistry. Again, you can only do that if you've been vigilant over the last decades of making sure that you audit the precip chemistry, the analytical techniques, you're able to combine them with known and consistent accuracy. And so we're able to look at this global distribution of, I think this one is multi-year annual average composition of precipitation chemistry, rainwater chemistry. And you see some of the techniques they've developed for identifying the confidence in those measurements. So again, long-term data enables these sorts of studies to take place. High-quality long-term data also enables global assessments and analysis, for example, including understanding of atmospheric processes. This is a cartoon that Martin Schultz put together, but I think it nicely demonstrates the way that reactive chemistry and other components that are being taken by GAW and the other communities, precipitation chemistry, the aerosol, are really able to, when put together in the context of, in addition with modeling and other thought processes, can really begin to look at both a lot of important issues of atmospheric chemistry, air quality, and climate. And these are, again, another way that we can use these long-term data sets. And a critical component of GAW is the capacity building, training, twinning, and more. And this is just a nice collection of some of the photos that have been collected for our celebration here. Just want to point out a few. the expansion, the establishment of these global observing sites was not easy. First you had to secure the money, but then you had to go about actually getting the money out of WMO and spent on the establishment of the stations and trying to get electricity to the station and all the practical things. And certainly one person, I don't know how many people in this audience recognize Bernard, but Bernard from NOAA was certainly a character and is a character, but certainly is played a critical role. And we see some other people. We see Ali in the audience that's played a very important role. Oh, here we go, up here. And then certainly Jorg has been very active in helping us establish this capability of these instruments. And then I say and more because these relationships that are built is not just about getting a measurement established or continuing that measurements, but it's building a community. And certainly here's a great example, Lisa working very hard in terms of promoting women in general for capabilities to move on into the atmospheric sciences in general and into if they end in meteorological services and moving the GAW program forward even better. So. These long-term commitments to observations are also critical to GAW, and I think critical, and that's one of the things that the meteorological community can bring to bear if they're committed to this in the long term. This is a great example. I love this slide. In terms of Indonesia, established a global station back in 1995 with a very limited number of parameters. Okay? And then you just look at the time period over the years, you see the expansion of that. We're expanding now most recently into the aerosol areas, stimulated in large part. Switzerland has been one example of a great country that's very much behind the GAW program. They've really worked hard at expanding aerosol capabilities in some sites, and this is one of them. I really love this slide, both from the fact that it's evolving and showing how a commitment can lead to better things, more parameters that are driven by the interest of both the local areas as well as the broader community. I also love the pictures of, again, building activities, and I especially like to point out to my students and other students and postdocs, and be very appreciative of any new equipment you get. Okay, you should celebrate your new equipment. It's not. Don't take it for granted. Anyhow, okay. And then, of course, data reporting and dissemination are critical elements. We showed this slide yesterday, showing the top slide is the current snapshot of the GAW locations where data is being provided, both from the background stations, the global stations, the regional stations, and contributing stations. But you see this rapid growth of a number of data sets being delivered under coordination with the GAW program, and I think that's great. Over on the right, we see some of the expansions of these stations and data sets. These are, I've just shown you a couple of the high altitude. We see the pyramid site that is taking extremely valuable information in the Himalayas, and close to home here, showing you here the Bolivian station that's been talked about a couple times already, the highest altitude GAW site to date, and really stimulating a lot of exciting activities within, I think, certainly within this region and certainly beyond. And certainly, I want to recognize in the GAW program, we've certainly been, GAW has been guided all along the way by dedicated leadership. And what I'm showing you here are two pictures here. So under the GAW program, WMO has a Commission of Atmospheric Sciences that actually goes back to, I think, prior to 1970. It started in 1957 as atmospheric composition. It changed in 1970 to atmospheric sciences. It has two main bodies, the World Weather Research Program and then the compositional component of GAW. And what we see here around the table are, I think, very important. So there's only been 3 chairs of that, of the GAW steering committee. This is Doug Welpdale from Canada. Around the table, you can't see it, but Anton Eliasson has been such a strong supporter of the GAW program, currently head of the Norwegian Met Service, and one of the reasons you're going to have food to eat after this, after my talk here, is because of Norway and Anton. Rumen Voshkov. So this is Cass. The first chair of the GAW committee, the steering committee, was Doug. The second one was Ustein Hov, who did it for 15 years. And then I'm the third, started just this year. But more importantly, as the Secretariat, and we see here a snapshot, I think it's circa early 2000. John Miller was the second head of GAW. He did it from 1991 to 2001, something like that. He was really the motivation, the personality that I think really was able to take this idea of GAW and really realize it. The first one was Rumen Voshkov, who did it for 2 years, and he had other capacities at WMO for a long time. And then in between, not pictured here because this is a real capture, Len Berry followed John from 2001 to 2006, then followed by Lisa, who did it up until July of this year, and just retired in July of this year. And then Oksana is the next in line. And so I think we've had great leadership in terms of the Secretariat in support of GAW. So finally, let me take just a couple minutes here and talk about what's next. Okay, so we've had 25 years. While much has been accomplished over the past 25 years, GAW will continue to evolve in response to societal needs. Okay, so we've had a good run, lots of challenges along the way, of course, as any organization that relies a lot on goodwill. And helping us now, we're now beginning, we have a new scientific steering committee, and now we're thinking about what the next steps are going to be strategically, and we've begun to stand up the steering committee. These are the current members, and you can see again this strong connection to IGAC. All the parties here have been intimately have been or are intimately involved in IGAC, and certainly you can see too in the audience we have Paul and Melita. And we're thinking about working with everybody else in the SAGs and their membership to think about what the next steps are. So to set the tone for where we're at here, and what's emerging from WMO also is this idea, the recognition, the need to reduce risks to high impact weather. And I love this slide because it illustrates again, this is a slide that UNDP put together just recently in terms of multi-hazard exposures globally, and the relationship to the city size. And you see a lot of things from this. You see there's a correlation. Many of the large cities are sitting in areas that are heavily impacted by natural disasters. Most of those are high impact weather related. You also see that a lot of them sit in the tropics or near tropics. You also see a lot of them are in the coastal environment. So there's lots of these elements coming together in order to manage. And if you look at if I superimpose on here the maps where we have the highest pollution levels, you'll see that there's also a strong correlation. So it's not just risk to high impact weather, but the recognition that one of the elements of high impact weather is also high air pollution levels, okay, is being recognized as an element of high impact weather from WMO perspective. And certainly GERME has been put together to really focus on these high impact urban environments and developing observing systems and prediction capabilities to deal with that. And that's going to be an element as we move forward in terms of thinking about high impact weather, at least in the smaller scale environment. And we're already seeing a lot of interesting activities standing up around this concept of high impact weather. I think a great example is certainly the Chinese Meteorological Agency. Shanghai stood up during Expo, a multi-hazard early warning system that the WMO GERME pilot project played an important role in terms of looking at the air pollution and public health component. But within that, trying to understand the observing system and modeling predictive capabilities and dissemination of that with all the representative agencies to deal with heat waves, cold waves, rainstorms, lightning, air pollution, typhoons, all the things that impact these environments that put risks to people living in these environments. And so what they've done is they stood up this pilot project, but now has actually transitioned that to operations. And so severe weather, air quality, climate extreme quality weather, interacting with a whole host of stakeholders. And I think this is one example of services that are being stood up that have a strong research base that interact with our domain in these integrated urban weather, climate services, and supporting research. And certainly another aspect of that that's certainly high on the radar screen, and we've heard a lot about it in this conference and will continue to, the role of aerosols. A lot of interest. Clearly, aerosol science is really interesting. A lot to learn about how they're formed, how they modify properties as they age. Certainly how they interact with weather systems is really important questions. Met services around the world want to know, how much aerosol do I need to have in my model to improve my metric that's very important to my operational center? That's an important question for us to be thinking about. So again, the aerosols and interacting and bringing together the understanding of the science community and the predictive capabilities for this high impact weather is a great opportunity. So with that, those is just a couple of motivating slides. So where are we going next? We're just beginning to think about this, but clearly we're going to advance observations and analyses of chemical constituents of the atmosphere and UV radiation to help reduce environmental risks to society from high impact weather and air pollution, and to mitigate the impacts of and adapt to changing climate. So those are the key words that we're moving that will place us in the context of important society and also important topics within the WMO strategic initiatives moving forward. And some of that will translate to continuing to improve the observing systems and data processing to allow near real-time provision of GAW data. Another important component. It's not enough just to take a good data. Many of them need to have applications can serve in near real time. Support the integration of surface, vertical profile, and column data sets from different platforms to provide a unified understanding of aerosol and gas distributions. Minimize gaps in the measurement networks in data poor regions, both in terms of geographical location, but also in terms of parameters. Support the service needs of megacities and large urban complexes, and track trends and support conventions and assessments. So those are our thinking right now, and over the next year we'll be developing a more concrete implementation plan. So with that, again, thank you for allowing us to and joining us in the celebration of 25 years. Sitting here and hopefully being introduced to a little more understanding of the GAW program and its where it is, where it came from, and where it's headed. I do think that we have a great opportunity within GAW working with the community. Certainly we want to give our thanks to the many who have contributed to the GAW program over the years. Again, this is largely built on the village and the shoulders of interested scientists and dedicated individuals. And clearly we look forward to continued and expanded collaborations around the globe to carry out the observations and the research needed to enable better services. So with that, I'd like again to thank you. I will ask then, again, I mentioned earlier that we're going to soon adjourn, and we're going to have some refreshments and a small reception, and that was made possible by Norway. And again, I mentioned Norway has been such a strong supporter of the GAW program over the years, and their leadership has played leadership roles within GAW, and so I'm glad to introduce Michael here to come up and say a few words.
Yeah.
Thank you. I prefer walking around while I'm talking. Some of the photos you showed made me feel like a young scientist. I did not even know that Anton Eliassen was sitting in that committee in 1988. My name is Michael Gauss. I'm not a young scientist anymore, but I'm working at the Norwegian Meteorological Institute, or Met Norway, as is our official acronym since last year. And during the next hour or so, I will be talking about the history of Met Norway since 1866. And why are you laughing? And our scientific strategies during the last 4 or 5 decades. Okay, I try to be funny. I'm going to show only one slide. And the reason is because I want to make you understand why we are supporting the celebration this afternoon. It's not only to make commercial for ourselves, Met Norway, but it's actually because we like GAW, and maybe also because Anton and Øystein Hov have played significant roles in the entire program during the last 25 years. Anton Eliassen, maybe the young scientists among you, and there is still a lot left in the audience. Not everybody has gone to the beach. I'm happy about that. Anton Eliassen has played a very crucial role in EMAP, the European Monitoring and Evaluation Program under the LERTAP Convention. He's probably the only director of a meteorological institute who is at the same time a hardcore air pollution scientist. I'm not sure, but I think he's one of the few anyway. Øystein Hov, on the other hand, he is the director of research at Met Norway, and as Greg already said, he played also a very important role in GAW, and he's still giving input. He's also the president of the Commission of Atmospheric Sciences at WMO. Okay, as I promised you, it's only one slide. And after Greg's excellent talk, I can be short on these things. Because I want to give you a user perspective. Personally, I'm only a user of GAW data. I've never been actively participating in the program, but I'm a user, and I've been a user for more than 10 years, a user of measurement data from GAW. I just wanted to repeat some of Greg's points about the global view. We all know that GAW consists of many regional, also global networks which exist for various reasons independently, but GAW integrates them into a kind of global system. And as a user, I can always trust the quality, because there's a good system for quality assurance. There is a well-defined system for calibration, and Greg said that. Same units, same or comparable methodologies that are used. So as a Norwegian user, I can trust that measurements from South America or Africa follow the same criteria. And probably many of you know about the criteria to become a GAW measurement station. They are quite strict, and that's good. Also, long-term continuity is very important, and as was said by the previous speaker as well, it's part of the criteria to commit to long-term measurements. All this feeds into scientific results. And although I've been a modeler for all of my scientific life, I know that measurements are by themselves enough to make good science, to bring some good scientific results. Monitoring, detection, as Greg mentioned. One example being the ozone hole, of course, in the early 1980s. But personally, I can only talk about model evaluation. For that, it has been highly useful. I'm from the global modeling community, and I needed, in the early 2000s, a good system of observations to evaluate my model. Nowadays, Met Norway is also involved in operational services like the European MAC program. And as maybe some of you know, the MAC is making use of GAW measurements as well. And is a precursor of the Copernicus atmospheric monitoring service. That means operational services to inform both the public and policymakers. And that's what I mean by societal benefits. Giving good scientific results, helped by GAW measurements, we can inform not only the public, but we can help policymakers to implement legislations that make the world better. So, supporting science globally, by the way, that looks like a slogan. It's just my personal idea. It was my header here. I don't know if you agree, but I think that's an important feature of GAW. It's global, it's supporting science.